So I want to find the area of the interior of r equals 6 times sine theta. So the way I'm going to do this is by graphing 6 sine theta. So we know from pre-calc the amplitude is 6, the period is 2 pi, and so we're going to divide this into 4 pieces. So take 2 pi divided by 2 again. And then you have 3 pi over 2. Sine starts in the middle, and it's going to go to the maximum, middle, minimum, and back to the middle. So this is what it looks like. Now we can graph it. So think of this as the theta axis with the angles, and this is the r axis. At 0, theta and r is 0, 0. At pi over 2, r is 6. So pi over 2 is up here. R is 6. Now what happens between 0 and pi over 2? Well, theta is growing. Theta is going from 0 to pi over 2, and r is going from 0 to 6. So let's say if I pick a point in the middle here, that would be pi over 4. We know that sine of pi over 4 is root 2 over 2. Multiply that by 6 to get 3 root 2. So let's say it's something like that. And if you want to pick more points, but basically you're going to get a circle. Okay, now from pi over 2 to pi, well, I know at pi I'm 0. So pi is over here, it's 0. So pi over 2, we're up here, and then we go down to here. So the radius now, or r, is decreasing. Theta is still increasing, but r is decreasing. So if I pick a point here, let's say 3 pi over 4, that's the same point as this. So do you see that it's symmetric? Like if I was to cut it through pi over 2, these values are all the same. Okay. It's just the other side. So we get a nice circle. Okay, now what happens from pi to 2 pi? Or rather pi to 3 pi over 2. If 3 pi over 2, it's negative 6. Well, if it was positive 6, it would be down here, but because it's negative, we have to go back up here. So pi is 0. And let's see, let's pick a point somewhere between pi and 3 pi over 2. Let's say 5 pi over 4. So 5 pi over 4 is over here. But that would be negative. So we would plug it in 6 sine 5 pi over 4. That would be 6 times negative root 2 over 2, which is just negative 3 root 2. So that would throw us back here. Okay, so if you pick another point here, it will throw us over here. If you pick this point, it will throw us over here. So you end up getting this part again. And with a similar argument, if you pick angles from over here, r is negative, so it's going to take us back over here. Okay. So you end up getting the same picture from 0 to pi as pi to 2 pi. The question is asking to find the area of this interior. So obviously this is a circle with radius 3 because the diameter is 6. So you expect the area to be 9 pi. But let's use the formula. We know that the integral or the area is 1/2 the integral of r squared d theta. Okay, so what bound should I use? So the way I drew this picture was going from 0 to pi. If I go from pi to 2 pi, if I include pi to 2 pi, I'm double counting it. I'm drawing the picture again, which I don't want to do. So the area then would be 1/2 integral from 0 to pi. R we set as 6 sine theta, so we're going to square that. D theta. So 6 squared is 36. I'm going to pull that out. Half of 36 is 18. And then we have the integral from 0 to pi sine squared d theta. So keep in mind there's this, we can rewrite sine squared using the double angle identity. So sine squared is 1 minus cosine 2 theta over 2. So we're going to use that. The 2 comes out as a half, so 18 over 2 will be 9. Then integral from 0 to pi, 1 minus cosine 2 theta d theta. Integrate with respect to theta, I get theta minus sine 2 theta over 2 from 0 to pi. Plug in pi. Sine of 2 pi is 0, so I'm not going to bother with that. And then minus. If I plug in 0 for theta, I get 0. And then plug in 0 into sine 2 theta, I also get 0. So really, I end up with 9 pi, which is exactly what I expected. Next one. I'm given r is equal to 2 cosine 3 theta. And I want to find the area of one of the petals. So keep in mind, whenever you have an odd number in front of theta, so in this case it's 3, you're going to have 3 petals. Let's say if it was even, let's say if it was like 2 cosine 4 theta, you would always have to double that even number. So there would be 8 petals. In our previous example, we had 6 sine theta. Here, theta, the coefficient is 1. It's odd, so you would expect 1 petal, or rather like 1 loop. So in our example here, we would expect to have 3 petals. But we only want the area of one of them. Okay, so let's graph this. The way we're going to graph this is by first graphing 2 cosine 3 theta. We know that the amplitude is 2, so it's going from -2 to 2. The period is 2 pi over 3, because you always take 2 pi divided by b, which is the coefficient of theta. Now we're going to split this interval in half and in half again. And I find between pi over 3 and 2 pi over 3, that's pi over 2. Okay, so we know that cosine starts at a maximum, goes to the middle, down to the minimum, middle, and ends up at maximum. So whenever you have multiple loops, it's always good to find where the zeros are. So in our case, it's pi over 6. Actually, yeah, that's fine. Pi over 6 and then pi over 2. Okay. Now let's start here. So at 0, when theta is 0, r is 2. When theta is pi over 6, we're at 0. So what happens in between 0 to pi over 6? Well, my angle increases, so I'm going this way, but r decreases. So it should look something like this. Let's try that again. Okay, so whenever I think of pi over 6 as like an asymptote, you don't want to, go over it, because at exactly pi over 6 it's 0. Okay, so this part is done. And then from pi over 6 to pi over 3, we're negative now. Okay, so pi over 6 and pi over 3 is in this region, but because r is negative, it's going to throw us over here. Okay, so let's see how that works. So let's see, pi over 3 is over here, let's say, and then -2 So that would have us somewhere around here. Okay, and then from pi over 6 to pi over 3, so this region, so pi over 6 to pi over 3, you're getting bigger. R is getting bigger. So it looks something like that. So let me draw that better. And then from pi over 3 to pi over 2, so this region right here, that would correspond to this region because it's negative. R is getting smaller. So you'd have something like that. From pi over 3 to pi over 2, okay, that's finished. From pi over 2 to 2 pi over 3, that's over here, R is positive. So let's say 2 pi over 3, we're at 2. Let's say that's over here. And from pi over 2 to 2 pi over 3, R is getting bigger. So R starts at 0, and it gets bigger, reaches 2 when theta is 2 pi over 3. And it's good to continue this. So we'll add in another pi over 6, which will be 5 pi over 6. That's going to be 0. So from 2 pi over 3 to 5 pi over 6, it's somewhere around here. And then R is decreasing, so that will go to 0. And then if we had another pi over 6, it would reach a minimum. So from 5 pi over 6 to pi, we're in this region. And because it's negative, it's going to throw us over here. Okay, so from 5 pi over 6, the R is getting bigger. And we're getting, and that as we're increasing the angle. Okay, so what's going to happen is R is getting bigger, and then it's going to go to 0. Okay, so this was at 5 pi over 6. So this angle right here was from 5 pi over 6. Five pi over 6 over here, which is 11 pi over 6. Sorry. All right, so this was 5 pi over 6. Throw us over here, it's 11 pi over 6, which we can represent as negative pi over 6. So for our integral, I'm going to look at this area over here. It goes from negative pi over 6 to pi over 6. Then it's 1/2. R is 2 cosine 3 theta. We're going to square that, d theta. So 2 squared is 4. Bring it out. Half of 4 is 2. To go from negative pi over 6 to pi over 6. Then we have cosine squared 3 theta. We know that cosine squared is 1 plus cosine 2x over 2. So you're doubling the angle. So in our case, we're going to have 1 plus cosine 6 theta over 2. The 2 is going to come out and it's going to cancel. So we have negative pi over 6 to pi over 6. 1 plus cosine 6 theta, which is theta plus sine 6 theta over 6 from negative pi over 6 to pi over 6. Plug in pi over 6. Sine of 6 times pi over 6 is sine of pi, which is 0, minus, plug in negative pi over 6. Sine of 6 times negative pi over 6 is sine of negative pi, which is also 0. So pi over 6 minus negative pi over 6 is pi over 3. And that's the area.